Hello, everybody, and welcome to today's webinar presentation, Application Performance Management for Azure Databricks, brought to you by Unravel Data. I would like to introduce you to our presenters. Our first presenter, Ron Abelera. Ron is a technical strategist for Microsoft Azure and advises on modernization, migration, and cloud data solution architectures with the combination of open source technologies and partners for Microsoft. Our next presenter is Abha Jain. Abha is Unravel's Director of Products with over a decade of experience in the software industry. Having worked at both large companies and small startups, Abha has gained exceptional experience in both consumer and enterprise products, with numerous awards under her belt from VMware, Qualcomm, and Microsoft. Abha is a TI Fellow at Rice University with a master's degree in electrical engineering. So today in this webinar, we will be providing an overview of Unravel for Azure Databricks, which is a new offering from Unravel Data. First, Ron will be giving us an overview of Azure Databricks. Then Abha will walk us through Unravel for Azure Databricks. Then after that, we will open it up for the Q&A portion of the webinar. And with that said, I'm going to pass things over to Ron to begin the presentation.
All right. Hopefully everything is working okay. Thanks again, everyone, for joining. So once again, I'm Ron Abelera. I'm from Microsoft. I'm part of the Global Black Belt team. I've been working with customers over the past several years regarding big data solutions and solving a lot of their big data challenges. So I'm excited today to talk to you a little bit about Azure Databricks from a high-level perspective. What is basically used for, how customers can get value out of it to solve their big data problems and machine learning problems. So I'll stay high level, basically just to give you an introductory overview of what it does, as well as the different use cases where this applies in the various verticals that I see customers using these solutions to solve their problems. So basically, Azure Databricks is based on a technology called Spark. So for those who've been working in the big data space for quite some time, Spark is one of the hot keywords nowadays on being able to solve a lot of those challenges. So basically, what is Spark? So Spark is an open source technology. It's an engine built on solving a lot of those big data challenges, and it's extremely popular because it's really built around speed, ease of use, the ability to use a variety of different tools of choice out there for data engineers and data scientists. So it becomes very popular just for the speed factor and the ease of use. Traditionally, a technology called Hadoop was sort of like the mainstay solution for the last decade or so, but Spark has definitely been taking over just because from a sheer speed perspective and just the amount of tools and support out there. Because it is an open source project, there's thousands of contributors out there, including Microsoft. And the main company that has been contributing to the project is a company called Databricks. So Databricks is a company that essentially the founders were the main contributors to the Spark project. And that company is now in a partnership with Microsoft. So we're able to bring a lot of those toolings as a service on the Azure cloud. So the specific reasons why customers are moving to Azure Databricks and not just any open source version of Spark is that because they're the ones who founded the technology and are able to contribute a lot of the special sauces to the technology. They're essentially the premium version of Spark, right? They're able to understand, where the performance improvements can be made. So the version of Spark that Databricks has as part of their distribution is definitely more enterprise grade and more performant than other Spark versions out there in the market. So as I mentioned, Spark was founded by essentially the founders of Databricks. And is now one of the most popular workloads in the big data space. Because of that, they're the ones who really understand how to improve this technology. And now that it's a platform as a service on Azure, it makes it extremely simple for customers to just be able to spin up these solutions on demand, not have to worry about all the infrastructure challenges and all the logistical issues that traditional Hadoop clusters and other solutions have had to deal with before. So just kind of give you a difference of why, the old technologies of Hadoop and MapReduce are going by the wayside and really getting taken over by Spark. Is that for a lot of these big data challenges, speed is really the one of the main metrics to be able to for success for a lot of these companies. It doesn't matter if you have a big data challenge, and if it takes too long to process it, that tool really becomes no value, right? The sooner that you can get answers, the sooner that you can get results from all the number crunching and the data science that you're trying to do, the more valuable it becomes, right? We're becoming a more real world, event-driven from a technology perspective. So speed is king when it comes to these solutions. So in the old traditional MapReduce space, this basically breaks down the problems, but keeps writing to disk, right? As it gets answers and puts those results back on physical disk. So historically, that's been a challenge because disk is usually the slowest component of the actual physical infrastructure. So when it comes to the Spark ecosystem, very similar from a high-level architecture standpoint. It's still breaking down problems, right, and essentially distributing that to as many workers out there to essentially solve the problem faster. But the key difference here is that now we're actually using memory, essentially a cache layer instead of a physical disk, and this essentially results into 50 to 100x performance improvement. So even though the underlying strategy of basically breaking down problems, solving it with as many computes as possible, it's really the storage side that really gains the most efficiency and speed. And that's really why one of the reasons why Spark has become really popular over the past couple of years is that just for the same problem, you're able to solve that solution in less than half the time in many instances. And that equates to a lot of cost savings and other benefits for customers. So speed is the reason why Spark has been really popular lately versus Hadoop and MapReduce. So what's the difference between just Spark and Azure Databricks? As I mentioned, Databricks itself is a company that's contributing to the Spark ecosystem, but the Databricks company has now partnered with Microsoft to essentially team up with the Azure cloud to provide their solutions as a service.
Hello, Ron, are you there? Hey, Ron, if there's any way, could you please reset your sound? It is no longer coming through.
Is that better? Hello? Can you hear me now?
Yes, we can hear you now. Thank you so much.
What happened there? Got muted for some reason. Okay, sorry about that. Not sure where I left off, but basically the reason why Azure Databricks has been popular for many customers, large and small, is that really combines the value of the Microsoft Azure cloud, all the enterprise capabilities from security to reliability to availability, etc., across the globe. And it also combines the best of Databricks, which is all the secret sauce that they've been able to add onto the Spark platform from a performance standpoint, from the also enterprise-grade capabilities. These are all benefits that we've combined together. And one of the specific areas where a lot of data scientists and engineers love Azure Databricks is that it is the only Spark solution out there that has the one-click setup, the streamlined workflows. Previously, data scientists and engineers have had their own workspace to deal with, and sometimes that's not very good from a collaboration standpoint, and not being able to combine different minds together to solve the same challenges. So the fact that the Azure Cloud brings the ability for collaboration, shared workspaces, the ability to share resources and interact with each other, essentially now gives the power of Spark and all the other tools that Databricks offers, along with all the tooling that Microsoft Azure provides, to give our customers a seamless experience to solve these problems, not just faster, but better as well. So just a kind of a quick overview, Azure Databricks is definitely the new kid on the block, and it's been an evolution of various technologies. From an Azure cloud perspective, we've had some other technologies also in play. So for folks that have been working with Hadoop, there's definitely a lot of different options. And Azure HD Insight is our managed, essentially Hadoop offering as a platform as a service. But as you can tell, as technologies have evolved and the tooling has improved, Azure Databricks has now become the tool of choice. So even though that there's other tools available from a first-party service and the ability to be able to spin up these tools on demand, really customers are finding that the modern architecture when it comes to Azure Databricks is the way to go. So we are seeing lots of customers migrate and evolve from their traditional systems, whether it's on premises or in cloud, from other architectures out there, and looking at Azure Databricks to essentially consolidate and to streamline a lot of those operations and tooling into one location. And the good thing is that Azure Databricks is built on some of the foundational technologies that other technologies on Azure have been running on, including Azure Storage, Azure Data Lake. These are technologies that can scale up on demand, can accommodate as much storage as you need into the petabytes range. So this is a fantastic solution for customers to really not have to deal with all the logistical and infrastructure challenges, and be able to run a lot of their tools with Azure Databricks on Azure. So another reason why Databricks has been very popular is that a lot of the tools in the past have historically focused on one audience, right? Either it was a data science type of solution where they had access to ML, machine learning libraries and tools, etc., but may not have been the same type of tooling and workspaces and environment as a data engineer. Folks who are more interested in the ETL workloads, the more traditional database type of operations, right? Feeding that data to applications rather than crunching machine learning algorithms, etc., as well as the business users, whether it's the chief data officer, the VP analytics, or just the BI users in general. So the reason why these key three audiences are starting to standardize on a platform like Azure Databricks is that this one platform accommodates all of these audiences. So that's another way for that collaboration to happen, to come up with a little bit more of a DevOps technology philosophy of all these groups being able to work together to solve these problems together and do it in a fast and efficient manner. So underneath the covers, as I mentioned, the reason why those three audiences are able to collaborate under this one platform is that it doesn't matter what your data is, right? Whether it's batch data, whether it's coming from existing data warehouses, whether it's real-time streaming data from sensors out there across the globe, right? Or whether it's from legacy systems like Hadoop storage. All those different sources combines into this platform called Azure Databricks, which gives you that collaborative workspace across all those different personas, as well as give them streamlined pipelines and processes to be able to run their jobs, right? The multi-stage pipelines, being able to schedule their jobs, being able to schedule however many resources they want, and be able to plan that with other personas that are needing capacity as well, getting those notifications and logs if there's issues with their jobs, or if they're needing additional capacity, etc. And of course, underneath the covers, that engine, that diehard engine that just keeps all this number crunching up and running and doing it efficiently. All the goodness behind the scenes, whether it's the Apache Spark engine, right, or what Databricks has done to enhance the I/O, the ability to run high concurrency jobs, doing a lot of things in parallel, as well as providing REST APIs, so that way BI users or folks that are wanting to create applications or dashboards based on that data are able to do it very easily and seamlessly with just one platform. And of course, you can scale all these capabilities, whether it's machine learning, BI tools, right, data engineering tools, or data warehousing tools. So at the end of the day, this is a platform that has many tools and many bells and whistles to accommodate all of these different users and to be able to enable them and accelerate the different things that they're wanting to achieve. So behind the scenes, just kind of giving you a high-level architecture of the other Azure tools that are a part of the ecosystem. As you know, it takes a village sometimes to solve a big data workload, a big data challenge. So just kind of giving you an idea, just from an analytics, a big data perspective, there's always a process to be able to get that data, to modify and do something with that data, and then to actually do something with that data, to serve it and model it. So this is kind of a high-level overview of what happens in the Azure ecosystem along with Databricks, from ingesting that data using message queues or message technologies like Kafka or Event Hubs, storing it into a persistent big data store, and then using Databricks as that engine. As you can see, we have other options as well, and not of them as large as an ecosystem as something like an Azure Databricks. But then also going to other tools like Cosmos DB, SQL database, and to basically finally exit to the tools that they are actually wanting to use, from BI tools to analytical tools, etc. So this is kind of an overview of how, from a big data and analytics space, the overall architecture and the workflow looks like in the Azure cloud. So Spark and Databricks have also been well known into going into the data warehouse space as well. So it's not just data engineering, data science. Even from a modern data warehouse perspective, this is another high-level architecture of how, basically from an ingestion, storage, preparation, training, and then serving perspective, how Azure Databricks is part of that workflow. Many of you may have heard of the term the Delta Lake. That's something that the Databricks folks have been creating, and something somewhat fairly new, probably in the past year and a half or so. But Delta Lake has also been coming up more and more when it comes to data warehousing type of use cases. So this is just another high-level overview of what can be possible when it comes to using Azure Databricks for a modern big data warehouse architecture. And of course, advanced analytics, right? When it comes to machine learning, all those different algorithms, and tying it into a data warehouse, it all can be possible. This is just, once again, another overview of how you can do it from the ingestion perspective, where to store it, preparing and training it. As you can see, one of the big differences that has been added to this diagram is that from Spark has a variety of different ways that you can run machine learning algorithms, and this accommodates a lot of the different data scientists out there whether they're Python users, whether they're Scala users, whether they're R users. So there's Spark ML libraries, Spark R libraries, Sparkly R libraries. Once again, you can see how the results of that can feed either a data warehouse or even serving a NoSQL database like Cosmos DB when it comes to globally distributed applications. So hopefully these last 3 slides kind of give you an overview of essentially the high-level architecture of how our customers are able to build their big data solutions depending on what they're actually wanting to accomplish, whether they're trying to build an analytics store or a web application or just doing BI. There's a whole world of different applications that Azure Databricks can power. All right, so I'm going to transition to the different use cases. I'm not going to cover all of the various use cases per vertical, but I will cover a few today, just to kind of give you an idea of where we see customers using this technology to power very specific targeted scenarios. So the first one I want to dive into is in financial services. So whether you're a bank, whether you're a credit card processor, whether you're just you're a loan processor, knowing your customer is a very important part of not just being able to optimize your profit margins, etc., but being able to understand your customer helps you understand what type of products to be able to give out there, what type of price points. So customer analytics, being able to get a 360-degree view of what your individual customers are looking for, not only helps that customer become more loyal and stay and doing business with your organization, right? It reduces that chance of them, that customer churn and them leaving for a competitor, but it also improves that customer satisfaction as well. So customers have been using Databricks to analyze a bunch of customer information, to understand those various angles of the customer in greater detail and ask better questions and be able to give that customer a better experience on their products. Financial modeling, very popular just because Monte Carlo simulations and other ways to be able to price certain products and investment portfolios per individual is extremely important. You need to do it real fast, right? People are becoming more used to having data applicable to them in real time. So being able to get financial modeling and getting it tuned specifically for the individual, at the point of the customer asking for that information is extremely important. Risk, fraud, and threat detection. Security is a big deal, not just in securing, organizational infrastructure, but even from a personal standpoint, right? Knowing that something has happened, like fraud, and having that in real time is extremely important, so you can react appropriately. No longer is the day where you get notified, months after a breach has already happened. You need to know this almost in real time, so you can take, reactive measures to reduce the impact to your business or to reduce the impact to your customers and individuals. So risk, fraud, threat detection is extremely important when it comes to anything financial related, and that's where the speed of Spark comes into play here. Credit analytics, same thing. Being able to understand your customers a little bit more, right? A lot of information, a lot of data from the historical perspective and different sources to be able to understand, regulatory compliance, be able to figure out, what type of customer and what type of options that they have from a credit perspective and what type of risk is involved in being able to serve that customer. So credit analytics is extremely important. And that type of information has been crunched with Spark for quite some time. And of course, market analytics, being able to understand your customer better again, right? Being able to make recommendations. No longer is it where you just go into a store and you just have to figure out what you want. Many of these online retailers now and online financial services, etc., are able to proactively offer you various products that are tailored specifically for that individual, for that groups of individuals. So being able to understand your customers better is another important reason why Spark and Databricks is part of that solution. All Right. So in health and life sciences, once again, this could be the meaning of life or death for many people, right? A lot of medicines out there have been accelerated to market just because the sheer amount of compute power and being able to analyze what's effective and how they react to different things are becoming more popular when it comes to this particular industry, right? So genomics, right, and being able to do targeted medicine. This is only possible with the compute power of the cloud and with technologies like Azure Databricks, right? So that way we can take individualized data points, right, like a person's DNA, or their history, you know, their blood levels and all the results from the variety of different type of data points, and be able to understand that patient better, to be able to sequence their DNA and understand what drugs can be more effective, right, and help plan and do a more personalized treatment for that person. Also, when it comes to being able to serve medical records, right, this is a pain point for many people out there who just have to deal with medical insurance and medical paperwork. Has always been decades long problem of mistakes and errors and claims and delays, etc. So we're using machine learning and we're using big data solutions out there to not only make this a faster process, but also more accurate as well, to be able to provide the right data to the right folks at the right time. Deep learning imaging. This is another area of interest. A lot of scientists and have been spending a lot of time in this area, right? This has been a human-read type of process for quite some time, reading X-rays, reading CT scans, etc. Right now you essentially have computer-aided vision being able to help process those images and doing thousands and millions of those images with the accuracy that's improving and helping these doctors be able to identify quickly and early things like tumors and early indicators for cancer. All these things are based on pattern recognition of existing data points of what a cancer or a tumor image looks like, right? So now imagine being able to do this across thousands and millions of records. And this saves doctors time and is able to help the patients understand what their condition is, as well as help avoid some of the false positives and false negatives as well. So this is another area in the healthcare that Spark and Databricks have been assisting with and helping patients out there. Sensor data, right? All the blood pressure machines, all the different equipment that doctors use, right? These are all various data points that help them analyze as far as being able to predict, not only the machines going down, but if there's any health concerns that they may be dealing with the patient, being able to identify anomalies. So these are all great use cases in changing lives out there. And of course, social analytics. Once again, it's all about people, right? And how this relates from a family perspective, from their groups, being able to find trends and patterns across that data. Retail is probably one of the most common use cases that we see. Once again, this is about knowing your customer, being able to provide them personalized offers, making them recommendations ahead of time, and also being analyze their patterns to essentially help make more money and keep them as a happy, loyal customer. Also tracking their engagement to see how are they an active customer, right? Are they a customer that's going to have a propensity to buy more or to go to other locations. So it's really important to be able to streamline that, to make it easier for your customers to understand your product and to be able to purchase them very easily, to improve that customer sentiment and increase revenue. Stock ordering, right? Inventory. It doesn't matter if you're able to order something and it doesn't arrive on time, or they actually don't have that product. So basically, supply chain logistics is another way that all these data points can help figure out a streamlined way to get those products to you as soon as possible. Assortment optimization. a little bit, of a lower use case. I won't talk a little bit about that, but once again, this is about understanding your customer a little bit better. And of course, real-time optimization. Everything nowadays is real-time. You don't want to wait, several minutes or hours just to know what the price is, or what sort of a promotion is happening, and especially when those products are already gone. So the fact that it's a real-time world nowadays, the speed is king, and Spark is a big component of that. Okay. Same thing again with advertising and marketing tech. This applies for a lot of different verticals out there. So that's once again, it's knowing your customers, being able to understand them again, right? Being able to provide them with personalized offers. Once again, the risk and fraud management. There's a lot of crime out there, a lot of people that are spoofing, and these are millions and billions of dollars that are lost for retailers, for organizations when they've been frauded. So the fact that we can have some real-time analytics and to reduce the amount of fraud out there not only protects the consumers, but also protects the organizations that are trying to serve them as well. Sales campaigns and optimization. Once again, you want to be able to understand your customers, get ahead of the types of promotions and types of activities that you're wanting to do with them, increase that engagement activity with them. This is very popular in the advertising space. You want ads to be targeted, right? People are going to ignore ads that don't relate to them. So it's extremely important to have an idea of who's looking at the ads, what they're interested in, and being able to target the right ads for the right folks. Okay. Of course, sentiment analysis, just understanding how they feel, how they react is extremely important. All right, and I've touched a little bit about this on security, right? Being able to have all those data points coming in real time to see if there's a fraud, right? But also there's some reactive analytics that are happening behind the scenes, right? To understand, things that may have been happening and creating patterns that may not have existed at all. So this is very popular when it comes to things like internet security, dynamic denial service attacks. Those are extremely important because hackers are always one step ahead. So it's extremely important to understand what their patterns are. That way you can get ahead of them before you are suffering from a risk of a security breach or what have you. Security intelligence, same kind of thing. Be able to find that pattern, that correlation. That way you can actually be proactive when it comes to being able to identify those patterns, right? And be able to orchestrate activities based on any security activities that are out there. Fraud detection, we've talked about that a little bit, but prevention is going to be key. But you can't prevent something if you don't understand it. So it's extremely important to be able to use patterns and correlate them to understand if a fraud event is occurring. Security compliance and reporting. Every organization out there has to deal with some level of compliance and reporting. So Spark is extremely good at that as well as the fine-grained analytics, understanding even for individual user, right? What access should they want, or what access are they trying to request and not getting, and trying to access and penetrate, etc. These are some of the basis of things like multi-factor authentication out there. That way, we're preventing unauthorized access and be able to understand where those patterns are coming from, whether it's people from overseas, from different countries trying to log into your account, etc. Those are all data points that we can crunch and get some information from to be able to understand who's trying to do it, why are they trying to do it, what are they trying to access, and to make preventative measures moving forward. Okay? So I know I ran through that very quickly. So as you can tell, Azure Databricks has so many different applications out there. And I didn't even cover all of the different verticals and all the different use cases. But you can see the power of this whole platform and being able to do it in near real time. I wanted to share one customer with you today, and it's Lennox International. So for many of you that have an air conditioning system, you may know them as an AC manufacturer. But really, they're in the business of not only making sure that their customers are comfortable and cooled and have heating, etc. But they also have a distribution of equipment manufacturers as well as distributors out there. These are a lot of data points. These are a lot of information about their equipment. And at the end of the day, it's really about making sure your customer and your distributors are taken care of, right? So being able to detect things like equipment failures sounds very trivial, right? But if you ever had to suffer from 110 degrees of heat in the summer and your air conditioning fails and it takes 3 or 4 days to get a replacement part, you can tell that that is something that a lot of people have even lost their lives waiting for something as simple as just air conditioning. So Lennox is using the power of the Azure cloud and with using Azure Databricks to get all those sensor information to be able to accurately predict if there's going to be a maintenance issue, whether there's going to be a component that fails. So they can help their distributors order those replacement parts more efficiently, more smartly, and to be able to have more proactive services, have someone out there, an HVAC guy, to actually replace that component before they actually have an outage. So these are really important things that people are now taking the benefits of. So it's not just the fact that there are smart ACs out there, but the fact that these ACs will have better uptime and help the customers be more comfortable and not have to suffer from heat waves or from cold spells, etc. This is the power of big data. This is the power of the Azure cloud running platforms like Azure Databricks. So I really appreciate your time. Once again, I'm Ron Abelera. I'm here. I've been helping thousands of customers when it comes to big data solutions. We're definitely excited about the power of Azure Databricks and what it can help our customers with. Feel free to take a look at the Azure website. Just search for Azure Databricks, and you'll find so many pieces of information, different use cases, different ways you can get started, and different price points depending on what you're trying to do. But if you have any questions, feel free to ping me after the fact or take a look at our website. We're here to help you. There's so many challenges out there that are they're made possible and because of platforms like Azure Databricks. So we do appreciate your time, and I look forward to working with you and solving some of your big data problems. Thank you. And I'll just turn it to Alba.
Thank you, Ron, for the wonderful overview of Azure Databricks. So I'm going to just start with a little bit of an introduction of Unravel. So what Unravel does is provides application performance management and application performance management specifically for big data applications. So if you're running Spark applications, MapReduce, Hive on Thales, Hive on Spark, you have Kafka in environment, you have HBase. Basically, what we do is, what Unravel does is helps you run all those applications more efficiently and in a more performant way. So just a little bit about the company. We have a very experienced team of individuals from Cloudera. Our CTO happens to be an adjunct professor from Duke, and several of the very experienced people from Hortonworks and AppDynamics are also part of the Unravel team. We just closed our Series C a few months ago, and Microsoft happens to be one of the investors, and we are an M12 company. So as I was mentioning, what we provide is performance management for modern data applications. We provide resource and cost optimization as a result as well. And if you were moving from a modern data platform, which was on-premise, to cloud, we also help with detailed planning and assessment of that process. We do this by being able to collect and analyze data from the entire stack. Our insights and recommendations are AI-powered, and we can help with automated tuning and remediation of your big data, modern data applications. As in distributed systems, the problem is that it's very difficult to analyze applications, analyze all the data, and figure out what's going wrong. So our point is the whole surmise of Unravel is to make sure that nobody has to go through thousands of lines of code and or correlate a lot of system matrix to be able to figure out why applications were slowing down or failing. And that's basically what Unravel does. We collect very, very granular data about the infrastructure, about the system, about the applications themselves. We correlate and analyze all this data and give you very, very actionable and specific insights and recommendations to be able to run these applications more efficiently and in a more performant way. So as I was mentioning, we work on all different kinds of big data systems on the cloud or on premise. And today we'll specifically talk about the solution that we have built for Databricks. So in short, basically we provide application performance management and operational intelligence for Azure Databricks. The features and functionality include faster diagnosis and resolution of application failures and slowdowns. We help with ensuring that you achieve higher cluster resource efficiency. You get a unified view across all your Databricks workspaces and Databricks instances. We also want to ensure that you can run your applications reliably in production. We provide a usage breakdown and trending. We help with speeding up these applications. And then also, last but not the least, we provide a single pane of glass for applications, resources, data, and users. For this release, we focused on data engineering use cases and ensuring that applications can be moved faster to production in Databricks. And we analyze and optimize workloads which run on job clusters. All the 4 types of jobs, which is a notebook, jars, Spark Summit, and Python tasks, are supported. And the key thing to notice is the fact that you need a single Unravel deployment, which is able to run, basically able to monitor applications and workloads which are running across all your Databricks instances and workspaces. So with that, I've sort of broken down our functionality in terms of what we do for the applications and what we do for operations. And what I'll do is I'm just going to give you a quick tour of that functionality. So what you see here is that the main dashboard, and what you can see here is the relative, the use of resources. So you can see if what kind of resources are available and how much is being used. So this gives you a good sense of whether there's over-provisioning or under-provisioning going on in your system. And you can do this across all your Databricks instances, or you can choose a specific one to get more information on this. At the bottom of the screen is something we refer to as inefficient jobs. The idea is that we will tell you what are some of the things that can be done better with the applications which have been run across all these Databricks instances and workspaces. So I'll come to that in a little bit. Again, in case you also want to understand that if there is a spike in resource usage, hey, what was going on at that time? You can simply click and get a list of all the applications which were running at that point of time to get a sense of what was causing this kind of resource usage spike. You can do this, you can also look at the screens in terms of resource usage across workspaces or users, etc. Another thing that is very key here is to show the usage trending. So what you can see here is that over a period of time, how the resources have been used, how many jobs have been run, what's the trending been. You can do this, you can look at it for a particular workspace. For example, in this case, I just chose finance. And it's interesting to see that their usage is on a somewhat downward trajectory. Or you can see this across all your workspaces, and you can also compare and see, well, in this case, for example, finance seems to be running most of the jobs, while there's some smattering of usage by engineering and some by this workspace called Dev Central. So this is a useful tool for a lot of the folks who are managing the platform or looking at how the costs are trending, because this will help them have an ROI conversation with different teams who may be using different workspaces. A similar relative view can also be seen in what we refer to as a chargeback showback view. So once again, you can see that finance is running most of the jobs while engineering is running a few of them. You can also click on the various workspaces and actually get a list of the exact applications they have been running. This makes it even easier to have an ROI conversation with the team who may be using a lot of resources, and it'll be good for them to understand what's going on and what kind of ROI they're bringing to the table. The same kind of usage trending we were showing you in terms of number of jobs that were being run, but we can show that in terms of cost as well. Once again, this becomes a very powerful tool to have a conversation to understand how different teams are spending money in terms of running jobs, as well as understanding how this trending is going. because this really feeds into the kind of budgeting discussions you may have with your superiors and so on and so forth. One of the other things that as we were building out this product, we were talking to our customers, and one of the things they also asked us to help them understand is that how are the various tables being used? So basically, they wanted to see a trending of how many users are using specific tables or how the various apps are utilizing these tables. So in this case, as you can see, there's a sort of consistent use of this table called default diamonds, and once in a while we see a large usage from some other tables as well. In addition, you can actually click on a particular table to even get the list of the exact list of applications that are using this particular table. This is another thing our customers have mentioned is particularly useful. And one more thing I wanted to mention was that you can actually configure policies in order to decide which tables are hot, cold, and warm. And these policies can be set up just based on your own business priorities. And this can help you tier data in the cloud storage so that you can save some money for some tables which may be not used very often while ensuring appropriate performance for those that are being utilized very, very often. Now, as you know, you can see the list of job runs for a particular job. So we created a view that can kind of make it easier to look at how are the various runs of my job trending. So for example, in this case, it's pretty flat, while in this particular case, we see that there are sometimes spikes, and the same job being run on different schedules seems to be taking different amounts of time. Let's click on one of these. Now what you're seeing here is that you can see a trending of how the duration of execution has been for this particular job over time. You can also click on any particular instance to kind of compare the various runs as well. Now this is useful, but this trending is essentially showing you the duration of various jobs. Now let's say you wanted to figure out what the reason could be why there's a spike. You could actually decide to see how the data IO has been changing over time. Now in this particular case, it has been pretty flat. But had you seen a spike right here, that would give you a good sense of why there's a spike in the duration of execution as well. This is another thing our customers asked to understand better, because they wanted to understand that for a scheduled job that is running maybe every day, once every day or a few times every day, if it changes in execution duration, what could be the possible reasons? Now, this is how a particular Spark application that ran in Databricks looks like in Unravel. We have made sure that we bring in all the Databricks terminology, so it's easy to figure out which job you were looking at in Databricks, and then you can look at the same job in Unravel to figure out what are some of the improvements that could be done. So for example, what you're seeing here is a list of Spark jobs that run as part of this application. You can click on this to see basically the stages, the tasks, and so on and so forth. You can also see the Gantt chart. You can see various different configuration parameters. And then you can also see how the resources have been allocated over time in terms of cores and memory. And you can also see very, very granular information about every single driver and executor in the system, VM RSS, be it system CPU load, GC load, and so on and so forth. So all of this detailed information is very helpful. And somebody who understands Spark very well can utilize some of this information to run their applications for the next time more. They can improve it and make sure that applications run more efficiently. But for those who just want to get this, but it's not an easy task, right? So what Unravel has done is, instead of having somebody to go into all these different matrix and stages and details and try to figure out how to improve it, we have provided very, very succinct insights and recommendations. So first, in plain English, we explain some of the things that could have been done better with this application. And then all or some of these actually are changed into very, very actionable insights and recommendations. So what we're saying here is, hey, you ran this application with this parameter value being 2, and we recommend that you run it with 68. Notice that this application took about 7 minutes, 39 seconds to run. And when I did apply the Unravel recommendations and I ran it again, what I find is that this time it actually ran in less than 2 minutes. So this is something that our customers find very useful, because you can really speed up your applications. And speeding up your applications in the cloud, and especially for a Databricks job cluster, really means that you're going to save money right away. Another thing that our customers mention they struggle a lot with is figuring out why applications fail. It literally means that they have to get all kinds of different logs, pull them in, look at different system matrix and so on and so forth, and then analyze them for hours, losing productivity while they do so. So instead, what Unravel has done is that we do all this behind the scenes, and you can just get the answer in one click. So let's look at this here. Clearly, this application has failed. I click once, and here it is. Here's the reason for application failure, which in this case happens to be out of memory error for the driver and executor. And we also tell you a little bit about some things that can be improved in order to prevent this job from failing the next time. Another thing to keep in mind is that besides providing this succinct information about why the application failed, we also provide all kinds of other information in case you want to drill in right at your fingertips. For example, you can see the list of various errors, warnings, exceptions. You have the interesting logs right at your fingertips right here. And you can also see the various detailed configuration values, how things have proceeded over time. So it really makes it much, much easier to drill into reasons of why an application might have failed. And then one other interesting use case I wanted to mention, again, it came from customers like yourself asking for it, was basically, can you help us resize our instances? Can you provide us what is the best instance to use for our particular job? And so we added another type of recommendations, which is basically showing you exactly that, which is that in this particular case, we are saying that you use this particular worker type, which is standard DS4 V2. And our suggestion is based on the kind of application you're running and the kind of resource usage you have, we suggest that standard DS3 V2 will do as well. And if you did that, and if this application was running for an hour or so, you're bound to save about this much, 1.215 per hour. And this really is, it by itself, the number doesn't seem very large, but imagine if you had been running 100 such jobs in a day, which each ran for an hour. And if you ran these for, over a month, you would save more than $3,200. And over a year, that comes up to be, 40,000 plus. So that's a huge amount of saving that Unravel can bring you right there by suggesting what is a better instance type to use instead of the one that you may have used for a particular job run. I think one of the questions that may be lingering in everybody's minds would be, how would we set this up? And it's pretty easy. It's literally a two-step process. The first step is bringing up an Unravel VM, which is going to have the Unravel software and the UI that you have been looking at so far, which is right, I'm depicting it right here. And the second step is just to include an Unravel init script every time you bring up a job cluster. This screen is showing you a little bit of the architecture in more detail, but literally it's a two-step process. Set up an Unravel VM, which remains a permanent fixture, and then use a Unravel init script every time you bring up a job cluster, and you can get all these different benefits. So thank you so much for spending the time to go over this with me. If you have any questions or if you want to talk about trying this solution out, please do reach out to us. And if you have any questions as well, please do so.
Great. Thank you all so much. We do have a few questions that have come in. The first question that we have today is, how does Unravel collect Azure Databricks usage data?
Okay. So as I was showing you in the previous screen where we talked about how an Unravel init script is included, basically we collect data from Resource Manager, we collect data from executor logs, and we have very granular application level data being collected by so-called sensors, which come up at the time of the application, when the application is run as part of the JVM itself.
Great. The next question that we have is, my company wants to charge back Azure Databricks usage to departments. Can Unravel help me with this?
Absolutely. If you recall, we were showing you a few screens where we were calculating the cost per application, and the same cost per application can be aggregated per workspace or any kind of custom tags that you may be adding to your clusters as well. So that's how you can get a chargeback / showback kind of report for every single cluster, every single department, or whichever way you want to group by various applications.
Great. The next question that we have is, can Unravel help me gain insight into migration from my on-premises HDP cluster to Azure Databricks?
Absolutely. Indeed, since we understand so much details of such fine-grained details of every environment we are monitoring essentially. For example, it could be a on-prem CDH HTTP MapR cluster. Since we have such fine-grained details about all the applications and the infrastructure, we can actually provide you the suitable cloud topology you need to move to in case you are going to go to the cloud. For example, for Azure Databricks as well. And not only that, we will also tell you how much it would cost you going forward if you were to move all these applications to the cloud.
Awesome. We do have one more question. So audience, if you do have any more questions, please post them into the questions panel. The last question that we currently have is, how does the Azure Advisor compare with Unravel?
Yeah, so this is a little bit different in the sense that, as you noticed, we provide very, very application specific insights and recommendations. For example, what are the parameters that could be tuned? There is some amount of learning going on as well. So it's very, very specific to the applications that you're running. So in that sense, it's different. The same resizing algorithm that we use, in the same way, the resizing algorithm that we use is also very specific to each and every job. So you can actually tune your application. You can actually do tuning at every job level. So that's why it's much more powerful and specific to your environment and applications.
Awesome. So that was the last question that we have. So Abba or Ron, is there anything you would like to add before I close things out?
Well, I just wanted to thank everybody in the audience, and I welcome everyone to try out Unravel for Databricks. Please do reach out to us. The email address hello@unraveldata.com is on the screen. So I'm looking forward to hearing from you in terms of either wanting to try this out or any other questions you may have.
And yes, I'd like to just re-echo that sentiment. So thanks for your time and that we're here to answer any other questions. So I look forward to talking to you.
Great. Thank you guys so much. And a couple last thank yous. I want to thank Abba and Ron today for the great presentation. And I'd also like to thank today's sponsor, Unravel, for providing the audience with the great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you further your developer career. Have a great day, and we'll see you next time.